Hi and welcome to another Motec webinar. My name is Pete Swinney and today's subject is ignition tuning basics in an M1 ECU, and specifically in relation to the GP range of packages. Okay, so within the GP range of packages, the ignition tables and so forth work pretty similar to the M800. One of the main differences that you'll see is the vertical axis of the ignition map is always engine load normalized. In fact, it's the engine load normalized channel. I'll switch over to the M1 tune just to show you what I mean. Okay, on the ignition table here you'll see an engine load normalized channel, and like all M1 tables, the axes are actually fixed, so they're fixed in the package and you can't change them. But a number of tables have channels that can be derived from calculations or other sensors. So the engine load normalized channel is one of those. So we have actually three ways of configuring how that engine load normalized channel is derived or how it's represented. If I put it really simply, we can run an engine load normalized channel the way as an engine load representation, or we can run it from manifold pressure representation or throttle based representation. So we'll just go into it in a little bit more detail. So three options, as I said. In the normal mode, the engine load normalized channel, it uses efficiency and inlet manifold pressure to calculate an estimated load on the engine. It also uses inlet manifold temperature as well, and based on those three parameters it decides how much physical air is entering the engine proportional to its capacity. So as an example, if we were at full throttle on a naturally aspirated engine and we had 100 kPa in the inlet manifold and we had an engine efficiency number of 100, so that's 100% efficient at 100 kPa, this would mean that the engine is inducing its cubic capacity per cycle. So if it was a 4-litre engine, we're saying at that point that it's moving 4 litres of air through itself per 720 degree cycle. So if I give you another example, let's say it's the engine's now at 50 kPa manifold pressure, so the butterflies are nearly closed. And again, let's say that the engine efficiency at that point is still 100. That would mean that the engine load normalized channel, and all of these examples assume a 20 degree inlet manifold temperature measurement. So that would mean at 50 kPa, the engine load normalized channel would be 50%. So for our 4-litre engine, we would be then theoretically inducing 2 litres of air per cycle. Now obviously, knowing the true load on the engine, which is in fact the cylinder pressure, gives us a nice channel to plot ignition timing against. So another example for you, if we had a turbocharged engine and it was running 1 bar of boost, so that would be 100 kPa of boost. That means the inlet manifold pressure would be reading 200 kPa. Again, I'll stick with a 20 degree inlet manifold temperature measurement, and again we'll say that's 100% efficiency or 100% efficiency in the efficiency map, which is probably quite difficult to achieve. What that would mean is the engine is inducing twice its volume, so it's got 200 kPa at 100% efficiency, so that would be 8 litres of air per cycle. So that would be pretty efficient at that, you'd have to say. And that would be your engine load normalized would be 200%. So if we go back onto tune, if you were to convert this to a turbo engine, this is currently a naturally aspirated engine, you would need to go to A for axis and engine load normalized, maybe generate a new table. It's nice and simple to do. 0, maybe this thing's only going to run to around 220 kPa total, so we'll go 240 in increments of 20 kPa. Currently that's 13 sites required out of 21. We go OK. So now you'll see we have engine load normalized going up to 240%. Alright, so I'll go back to my example. And we're at the same boost now. Let's say we're at 1 bar of boost, so that's 200 kPa of inlet manifold pressure. But this time we've got a more realistic, well not more, let's kill it bad. It's got some bad exhaust back pressure, just so I can keep the numbers even. And so now our engine efficiency number has fallen all the way down to 50%. So at 50% engine efficiency, at 200 kPa inlet manifold pressure, at 20 degrees inlet manifold temperature, this would mean that it's an engine load normalized value of 100%. Now that makes sense. We've got half the pressure, 2 atmospheres if you like on the engine, but only at 50% efficiency. So only half of it's making it through the engine. So that stands to reason that the total engine load is at 100%. In other words, a 4-litre engine at 1 bar of boost with 50% efficiency in the efficiency map would mean 4 litres of air flowing through. So again, this gives you, the engine load normalized channel gives you a nice consistent channel that reflects pretty much cylinder pressure. And it gives you the ability to put in some nice flat ignition timing table numbers that will give you sort of a predicted amount of ignition timing for any given engine load. So you can pick a couple of points, get the ignition timing right at that, and if you can't, for instance, get to a couple of points on the map at this particular test, your consistent linear interpolation should predict what the ignition timing would be for a given engine load or measured engine load or calculated engine load on the engine. Alright, so that's a long-winded way of telling you about engine load normalized. Now, if you don't like all of that and you just want to go back to my old-fashioned numbers that I've always used based on inlet manifold pressure, you just type in 2 in the mode, and that will give you pretty much a 1-to-1 inlet manifold pressure as your engine load normalized channel. What it actually means is that at 100% it gives you 1 atmosphere, which is 101 kPa. And if this is a naturally aspirated multi-throttle body engine like this one, then you might want to do your ignition mapping based just on throttle position. Again, you could still use engine load normalized, but throttle positions might be what you've got ignition numbers for from a previous tune-up, and you may want to have that as a 1-to-1. So simply by entering into mode 3, throttle position then becomes the made feeding sensor that feeds the engine load normalized channel. So just flicking back again, mode 1, engine load normalized using the efficiency map number, inlet manifold pressure and manifold air temperature. Effectively, this goes up and down according to a channel that represents cylinder pressure. Go to mode 2, it effectively becomes kPa, and mode 3, it effectively becomes throttle position. Alright, so that's the basics on how to set up your ignition map, and there'll be further webinars on this subject and similar subjects, so keep an eye out for them, and thanks for listening in.